all right, let's go, people, let's go. Hey, if you're not subscribed, please subscribe, throw a like, let me know how I'm doing. I appreciate it. There's a free PDF in Spanish and Espanol down below in the description. Okay, we're going to solve systems of equations using the graphing method. This is called graphing. So the goal is to find the point where this linear equation and this linear equation intersect. So it's called the point of intersection. It's the only point where they'll intersect. Well, there's actually three possible solutions. They'll intersect at a point. They'll intersect at no point. That means there'll be no point of intersection. And then they could intersect at every point, which is infinite points of intersection. All right, so there's three possibilities. 1 point, no point, or infinite points. Okay, let's do it. This first line, I'm going to graph using y equals mx plus b. There's my y-intercept, -1. And my slope is down 3 over 2. So I'm going to go down 3 over 2. I'm going to do it a couple times. With the graphing method, you want to make sure you're really, really accurate. So this is important. Accuracy is important. Notice I gave you these little icons. All right, so for the first couple, I give you an icon, and you know that the line you graph is going to go through one of the icons. So notice how that line went through an icon. Okay, now I would put arrows on the ends because it goes on forever. But because I'm just using this as a tool for order of operations, I'm just going to go ahead and graph them without the arrows from this point on. This is also in slope-intercept form. That has a y-intercept of 6 and a slope of up 2 over 1. Remember, when there's no fraction, you can make it a fraction by putting it over 1. And then I'm going to draw that line. And again, you want to go through the icon and you want to be as accurate as possible. All right, so there's that line right there. Notice how it went through an icon. Okay, so it looks like we have a point of intersection right there. So that point has an x value of -2 and a y value of 2. So that's it, -2, 2. And you're good to go. Let's try the next one. Well, you know what we're going to do first is we're going to check it. So we can check our answers pretty quickly. So I'm going to go to my calculator and I'm going to put in -3 divided by 2 times, now I'm going to put my x value in, -1. And if I did it right, my output value, my y, should equal 2. And it does. Let's check the other one. 2 times -2 plus 6. And it also equals 2. So that means that I'm accurate, and that is the point of intersection. Okay, let's do this one. This has a y-intercept of -2, and then a slope of up 5 over 3. I'm going to do it again. And look, we land right on that icon, so that's good news. All right, I'm going to graph that line. Again, make sure you're as accurate as possible, please. All right, now I'm going to go ahead and graph the other line. The other line has it's in standard form. So when you're in standard form, you're going to find the x and the y-intercept. Let y be 0, and now solve that for x. So 8 divided by 2 is 4. So that's your x-intercept. Now you're going to let x be 0. Solve that equation for y. 8 divided by -4 is 2. So that would be that ordered pair. Draw your line. And find that point of intersection. Okay, so it looks like the point of intersection is going to be, I feel like I made a mistake. 1, 2, 3, 4, 5, 3. X-intercept of 4. Y-intercept of -2. Ooh, even I make mistakes, right? Okay, look at what I did. All right, so 8 divided by -4 is -2. Okay, you know why I knew I didn't do it right? Because I didn't go through that second icon. So that's good. You need to see me make mistakes. That's muy importante. All right, because I make mistakes, but then I try to problem solve my way through it, right? So that's important. All right, so I knew I didn't go through that icon, so I knew I made a mistake. There is the point of intersection. That is 0, negative 2. All right, all right. And we can check that one as well. I'm going to check this one, and then I'm going to stop checking after this. So I'm going to put in 0 for x. So 5 divided by 3 times 0 minus 2. And then I'm going to put in the 0 and the negative 2 in for y and x. Okay, so I'm going to put the 0 in for x, and I'm going to put the negative 2 in for 4. And what should happen here is the left-hand side should simplify down to 8. And it does. So we're good. That proves we are right. Okay, we're going to motor through this now. Let's do it. Okay, this has a y-intercept of 4 and a slope of down 1 over 3, down 1 over 3. Draw your line. It should go through an icon, and it does. So we good. We good. Okay, notice how I drive that line all the way through the coordinate plane. This is in standard form. So standard form means I find the x-intercept. Let y be 0. Divide negative 6 by negative 3. I get 2. Divide negative 6 by 6. And I get negative 1. That's the... Darn it, I did it again. That's the y-intercept. Oh my gosh. Okay. Back up. All right, I got the x-intercept of negative 6 divided by negative 3. That's 2. I got the y-intercept of negative 6 divided by 6. That's negative 1. All right. And now I draw that line. Woo. Looks like we're going to intersect right there. That's nice. It went through that icon. We good. So that point is 6, 2. So 6, 2. All right. That's good. Let's keep going. All right. Let's see if I can get this one right now. All right, this one has a y-intercept of negative 7. So I'm going to go to negative 7. Now my slope is a negative. That means negative 1 over 1. So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. Draw my line. Looks like I'm going to go through that little froggy icon right there. So that's good. That's good. Drive it all the way through. All right, now this has a x-intercept of 4 divided by negative 4. So that's negative 1. Let's see if I can get that right. I did. And it has a y-intercept of 4 divided by 2. That's 2. Okay. Woo. All right, now I'm going to draw that line. Make sure it goes through an icon. It does. It does. Boom. And it looks like our point of intersection is right about there. That's negative 3, negative 4. Okay, let's keep going, kiddos. Let's keep going. I think I'm getting it now. All right, this is a vertical line, right? Notice how there's no y value. So x equals, when I'm graphing a line, that's x equals a number. I go where x equals that number. And I draw the vertical line through that value. Because every ordered pair on that line has an x value of 2. Now this line is tricky. Notice how there's no y-intercept, right? Nothing in math means 0. Now the number in front of x is a negative 1 again. So negative 1 over 1. Really want to hit home with that one. So down 1 over 1, down 1 over 1. Looks like there's our point of intersection. So that's nice. Make sure it goes through the icon. It does. So it looks like our point of intersection is negative 2, negative 2. Okay, we made it. We made it. Let's keep going. All right. Now I'm going to graph these. Okay, this is the back side, the back side. All right, so this first equation's in slope-intercept form. So let's go ahead and graph it as a y-intercept of negative 4, and then a slope of up 4 over 5, up 4 over 5. Let's graph it. Ooh, there's no icons. I got to be more careful here. Got to be more careful here. All right. Make sure you're really accurate with these graphs because you get off a little bit. It really throws you off. Okay. Okay, now we're going to find the x and y intercepts because it's standard form. X-intercept is negative 15 divided by negative 3. Negative 15 divided by negative 3 is 5. Ooh, that would be nice if that's the point of intersection. Negative 15 divided by negative 15 is 1. That's your y-intercept. That's nice. That happened right away. I like that. I like that. Okay. So it looks like your point of intersection is 5, 0. 5, 0. Okay, both of these are in slope-intercept form. So I'm going to plot my y-intercept of negative 2, up 1, over 2, up 1, over 2, up 1, over 2. Draw that line, please. Be accurate now. Be accurate. Okay, now I'm going to go ahead and graph this line. That has a y-intercept of 4. And I go down 5, over 2. Ooh, it landed on that line again. I love that. I'm loving that. That makes it so much easier when you land right on the other line and you're graphing one line. So that solution looks like a 2, negative 1. And again, I just want to reiterate, you can check this pretty easily. If you want to get an A on something, you should always check. Put in the 2 for x, right? Boom. And I get out a negative 1. Ooh, that's a good sign. That's a good sign. Now I'm going to go ahead and do it to the other equation. Put in a 2 for x. And I get negative 1 out there, which is what y should equal. So we're golden. All right, that's how you check your solution. Okay, let's do this one. All right, this has a y-intercept of negative 7. So let's graph this one first. And the slope of down 1 over 2, down 1 over 2. Graph your line. Notice if I applied the negative to the run instead, that would be up 1 and then over 2 in the negative, up 1 over 2 in the negative. Notice you get the same line, right? So the negative goes with the rise or the run, but not both. Not both. And there's that line right there. Okay, now the other line has a y-intercept of 5 and a slope of down 1 over 2, down 1 over 2. Again, I could go up 1, but then I apply the negative to the run, so I would go to the left 2, which is negative, right? Okay, so now I'm going to graph that. Oh, these lines look like, okay, I think I see it here. I think I see it. Notice those lines look like they're same distance apart. Those lines are called parallel lines. Parallel lines will never intersect. And I know they're parallel because they have the same slope and different y-intercepts. So that's how you know they're parallel. There's no solution. They will never intersect. So no solution. All right, let's keep going. That was fun. Okay, this has a y-intercept of 9. Woo, I almost did it on the x. Now my slope is down 4 over 1. I'm going to do it a couple times. Okay, draw your line. Draw your line. Okay. There's that. Okay, now I'm going to go ahead and graph the other line. The other line, notice there's no x value, it's just y equals a number. So I go where y equals that number, and y equals a number is a horizontal line. Everywhere on the horizontal, y equals negative 3. So notice everywhere on that line, y always equals negative 3. Every ordered pair has a y value of negative 3. That point of intersection looks like it's negative 3, 3. Sorry, it's 3, negative 3, right? X is 3, y is negative 3. Woo! All right, that works. All right, let's do this. Last two. Okay, this has a y-intercept of 5. And then I'm going to go down 3, over 4, down 3, over 4, I like to do it a couple times for accuracy when possible. Uh-oh, my ruler's stuck on the table. Help! I got it. Okay, now I'm going to go ahead and graph that. There it is, right there. Okay, now this is standard form. Okay, so I have to find my x and y intercept. The number in front of x is a 1. The number in front of y is a -1. So to find the x-intercept, divide -9 by 1, you get -9. So that's my x-intercept, -9. To find my y-intercept, my x-intercept is +9. Divide 9 by +1, I get +9. My y-intercept is 9 divided by -9. Oh man, my y-intercept is 9 divided by -1, so that's -9. I got it. Draw that line. And let's make sure we're accurate here. Okay, it looks like we have a point of intersection right there. That point of intersection is 8, -1. 8, -1. I'm going to check that one real quick because, man, it just was out there and I don't know. So I'm going to check it. So I'm going to do -3 divided by 4 times 8 plus 5. Okay, I got -1. That's a good sign. Now I'm going to go here. When you do it in standard form, your goal is to put x and y in and get that number out. So x is 8 minus y is -1. Okay, and we got 9. All right, that's it. Good. I just needed to check that one. It was out there, and, I just wanted to make sure it was right. Okay, now we're going to do the last one, my people. This has a y-intercept of -2 and a slope of up 1 over 3, up 1 over 3. Okay. Draw your line. I think this should have been right there instead. I was a little low on that. Make sure you're accurate, please. Whoosh. All right, now I'm going to graph the other line. The other line has an x-intercept of -6 divided by -1. That's 6. Oh, there's my point of intersection right there. And then a y-intercept of -6 divided by 3. That's -2. What? There's another point of intersection. Hold on, what's going on? If I draw that line, notice what happens. They actually land on top of each other. That means every single point is a point of intersection. And there's so many that I can't name them all. So what I'm going to say is infinite solutions. Woo! There it is. That was fun, my people. That was fun. All right, stay strong. Keep working hard. We'll see you soon. Bye.